All today is about the angles of a triangle. All right, no side lengths today, all angles. Yesterday, I was trying to gauge your knowledge on what you knew about triangles, and all of you knew that all the angles add up to what? Okay, that actually has a fancy name, believe it or not. That's actually a theorem, all right? And it's called the triangle angle sum theorem. It's a mouthful, right? All three angles of a triangle add to 180 degrees, okay? And that's all we're going to work on today. We're going to become very, very good at the angles on the inside. And then maybe you've never talked about this, but you can also create angles on the outside of the triangle by extending a side. All right, so let's first focus on the interior angles. Basic problem here on example 1, I've given you all three angles. Find x and all the angles. Okay, if you want to draw a diagram, you can. If not, that's fine too. One of the angles is 2x. Next angle, x plus 10. And final angle, 3x minus 10. I just need one person to set up an equation for me to solve for x. Solve for x. 20, want to solve for x here, equation?
2x plus x plus 10 plus 3x minus 10 equals 180.
There you go. All three angles in a triangle add up to 180, or triangle angle sum theorem. Give you guys a second to show off your algebra greatness, which will get put to the test in a couple problems. Making somebody happy or disappointed from last year. And what do we end up with for your value of x? 12, value of x? 30? 30? Everyone all right with 30? All right, take it now, plug it back in. And find me all three angle measurements now. Take it, plug it back in, and then look at your angles and say, what type of triangle is this by its angles? Hey, 10, angle measures.
For 2x, I got 60.
60 is one angle, yes.
For x plus 10, I got 40.
40, and the final angle?
I got 80.
80, good. Now, I know we go so quick when we're doing tests and quizzes, but this check probably lasts you 5 seconds. How can I check pretty quickly that maybe I have the right numbers here, Kellen?
Just adding them up.
Yeah, they should equal what?
180.
180 when I add them up. 5 seconds. All right, if they don't, you probably plugged in wrong, or maybe you found x wrong. All right, 60, 40, 80, based on the angle. So don't give me isosceles, scalene, or equilateral. Based on the angles, what type of triangle am I working here with from yesterday? Oh, 14. Acute. All angles are less than 90. All set. Okay, next one I would highly recommend drawing your own diagram here because we got a lot of information. So let's help each other. Let's help each other. So triangle ABC, again, A, B, and C can go anywhere. They're just vertices of the triangle. Angle A, 40. So let's plug a 40 degrees in there. Angle C is 30. 30. All right, now you're going to draw a segment CD in that bisects angle C. So draw a segment CD in. So one endpoint should be on C. Point D should be somewhere on AB. Quickly, a little bit more detail. If it bisects, what's happening to this 30-degree angle here? What's it turning into 6? Which would be what and what? 15 and 15. Perfect. All right. Here's my purpose of showing you this problem. Not so you can hit buttons on the calculator and subtract. I want you to know we have 3 triangles in that diagram. Everyone see 3 different triangles? ADC, BDC, and the original one ABC. I want you to be clear that each triangle still contains how many degrees? 180. Everyone thinks, well, that triangle's in the bigger one, so it's got to be less than 180. No, baloney. Don't be embarrassing here. All right? Even though I have 3 separate triangles, and yes, 2 of them are in the original one, they all add up to 180. Every single triangle, the degree measure adds up to 180 for their interior angles. So I will let you go right now by yourself or in your group. We've already answered part B. ACD is 15 degrees. I'll let you find parts A, C, and D now. Remember, all interior angles of any triangle add up to 180. All right, let's see what you got for the angle measurements. How about angle B? Angle B, number 13. Angle B? 110. Nice job. $1.10. Now also, you guys may do this on your own anyway. Anytime it's a multi-part question like this, A through D, and I find one answer in a diagram, I add it in there because you never know. That may help me out later on down the line. How about ADC now? Angle ADC. 12, angle ADC. 115. ADC, I already have 40 and 15, right? I have a 40-degree angle and a 15-degree angle. And they all add up to 180. If you give me your 115, I don't think it'll add to 180. 100N, you might want to check again in the calc real quick. You got 40 and 15 already. $125. $125. Everyone good? 125. Now, you know, we're talking about interior angles of a triangle. So yeah, you could find this next angle by doing 180 minus 110 minus 15. But nobody says you have to do it that way. What do you know about those 2 bad boys? Linear pairs, yeah. All right, use any geometry. You have to. Anything goes here, guys. 20.
55.
55 degrees. Okay, nice job, everyone. All set? All right, let's keep going. I always, whenever I can, like to put give a ratio to you. So we got triangle ABC again. And you guys have 2 to 7, correct, on yours? Yeah. Yep, 2 to 7. So ABC. Angle C, 72 degrees. Ratio of 2 to 7. How we've been treating these ratios as far as it comes to either a diagram or writing the equation. What's up, Gracie? How have we been treating them? We've been attaching x's with them. Because I can't do much with the 2 and the 7 by itself, but once I plug, what do I multiply it by? X there. Now I can write an equation, which will be what for my equation here? Here you go, 11.
2x plus 7x plus 72 equals 1.
Yep. We can find x. When you're ready, what'd you find for x? 10, what'd you find for x when you're ready? 12 is correct. All right, and then it says find all the angle. I'm not going to ask for angle C already. We know that, but I will ask for angle B's measure and angle A's measure. So go back, plug in for X. Angle A. Eight, angle A. Nice job. And how about angle B? 17. 84 degrees. 5-second check. 24 plus 84 plus 72. Hey, it gives me 180. I must be doing right. Anything from you guys? Because I am going to different type of angle now in the triangle. Anything at all. All right, we've been talking about all these angles on the inside. We can also create an angle on the outside. Exterior angle. Take a side of a triangle and make it a little longer. You've just formed an exterior angle. So I need one person here to let me know, out of all these angles that are in my diagram here, which one would you consider an exterior angle? Name it. Which one would you consider an exterior angle? 15? Angle? This one? All right, that's kind of the vertice. 2, got it. Angle 2, definitely exterior. Everyone good? All right, now let's get familiar with some new vocabulary. I'm at angle 2. What would be the angle that's adjacent interior to it? Adjacent interior. So it's inside the triangle, adjacent to angle 2. And that would be what angle here? Oh, 17. Lowercase b. Yep. And here's the important term. If I have the adjacent interior, I can also have non-adjacent interior angles to angle 2. So still inside the triangle, but just not next to angle 2. And those would be what to angle 6? C and A. So angle C and angle A. Now, quickly here, I do not use the term non-adjacent interior. I don't know, it just seems, it doesn't go together, mesh well. So I use what's in parentheses here, which is remote interior. Okay, so you will hear me say remote interior other than non-adjacent interior. All right, use what you want though, but that's what I'm going to talk in class with. All right, we're not done yet. Give me another exterior. Oh, we're rolling. 14, 3. If 3 is the exterior, what's the adjacent interior? Here you go, 13. Angle C, but lowercase. I like the exact description. What would be my remote interior angles then? My remote interiors here, 22. Angle B and A, lowercase. All right, I'm not going to ask anybody. The next one, just process of elimination, right? Angle 1, angle A, and angle B and C. There is a special relationship between these angles up here. Well, we know these equal to 180, right? Agreed? Well, you're about to find out what's so great about those right now. Okay, ready? And sorry for anybody listening at home because now I'm going to the whiteboards and doing this. I'm going to put up 3 diagrams right now. I want you and your group to find the missing angles from each. Okay? These are all straight lines too. Not drawing the scale either. Okay? I'll give you guys, just to talk about it, what those angle measurements are.
So we're missing 40 in the
Angles are not drawn to scale. Ready? What do you got for my missing angles here? We can just yell them out. Here we go. 60 and yep. Here.
130 and 110.
Oh, one. Okay, gotcha. 130. Yep. All right, there is a pattern and a relationship up here. I know it's tough to see. Oh, they're not all divisible by 5 or 10. That's not what I'm looking for. Some are obtuse, some are acute. That's not what I'm looking for. All right, I'd like to try to find out, get a little bit more detailed here. Let me help you out. Diagram 1 over to the left. What was the exterior angle? 120. You see another 120 in that problem at all? 80 and 40 give me 120, don't they? What's my exterior angle here? Any other 110s here?
40 and 70.
I know I could have done the other, but that's not the ones I want. 130. What am I boxing in here every time? The remote interior. So you just discovered a new theorem here, which says what were these angles on the outside? Any exterior angle of a triangle is equal to what? The sum of the two remotes, because I got to add those up. Oh, notebook was in the way. Had it. By the way, is that anybody's notebook that's been there since like week 1? Okay. Maybe another class. Or Bethlehem lacrosse hoodie up here too. That's been here since like week 1.5. So an exterior angle of a triangle is equal to the sum of the two remote interior angles. Oh, good. Let's apply it. A very basic one here, for example, 1a, or just example 1. I know, hey, I know, I get it. A way you could do it is 180 minus 40 minus 90, get that interior angle, subtract it from 180 to get the exterior. Okay, I want to get there quick, though, using this new theorem we just showed you. X is what type of angle? So you're like, whoa, hey, it's an exterior. I know the exterior can be found by adding the two remotes. What are the two remote interior angles here? 40 and 90. Look how quick we'd go here. 130. And I know most of you say, well, why do I even need this theorem? Because look, right? I could have found that angle and then just subtract it from 180 to find that angle. All right, well, guess what? That doesn't work for example 2. And you'll see why pretty quickly. You just can't always rely on knowing all the interiors. Angle A, x squared minus 6x. How many of you now are sweating because you're nervous? X squared, huh? Woo! Angle B, 2x minus 3. And ACD, please locate that angle. Where's that angle? It's an exterior, yes. All right, that's why you can't pull what you maybe some of you wanted to do up here and go 180 minus this, minus this. You can't do that here. All right, they're all variables. But I can apply my new theorem, which says, what's your exterior angle? 9x, that exterior angle, 9x plus 27, is found by taking the remotes. What's one remote interior? X squared minus 6, and adding it to the other remote interior, which is 2x minus 3. And I hate to break it to you, the geometry part of this is done. It is done. Now I need all the algebra superstars to come out. Ha! I'm just going to clean up the right side because you can combine like terms. I'm just going to clean it up a little. And write x squared minus 4x minus 3. Oh, well, my eyes light up because I see this bad boy right there, the squared. And anytime I see a squared, I'm thinking sooner or later, I'm going to have to do what? Factor. Factor. Some of you guys that said square root, okay, I understand that, but there's also x's up here as well. If it was just x squared and all numbers, no other variables, then yeah, that would be fine, but can't do square roots with 9x and 4x hanging in there. So you're right, factor. I believe, though, they tell you that you can't factor unless what happens? One side equals 0. I always like to have my x squared positive, which it is right now, so I'm going to move the 9x over. How? Subtract it over. Yep, so what am I going to have on the right side? 27, huh?
On the right side.
X squared minus 13x. How do I move this 27 over? Subtract it, and what will it make on the right side? Minus 30. All right, here we go. It is time to factor. You need to find, and this is a tough one. So I have x, I have x. Two numbers that do what here? You're playing a little game in your mind. Two numbers that, how's this number involved? Multiplies to that and adds to negative 13. This is a tricky one because you're going to think of a pair right away and it may not work. So I'll let you discuss it. Remember, it's got to multiply to negative 30 and at the same time add to negative 13. I know you're going to think of a pair right off the bat, but it may not work.
Is 9x plus 27 plus that is equal to 180?
Say that again?
So the x squared minus 4x minus
3.
3.
Yep.
That is supplementary to the 9x plus 27.
Because this is exterior angle equals the sum of the two remotes.
Oh, okay.
And then I combine these like terms. Okay? I'm not saying any angles are equal at all. Did we find those numbers? Did we find them? 21, did we find them? Oh, I'm not there yet. Not there yet. I just want the number.
Positive 2 and negative 15.
Negative 15, positive 2. You guys that thought 10 and 3 pretty quickly? Okay. But you cannot get 10 and 3 to add to a negative 13 at the same time as multiplying to a negative 30. That just no combination does it. All right. Solve for x. So over here, x equals 15. And over here, x could also equal negative 2. Are we going to have this awkward staring contest till somebody speaks up? We'll keep having that staring contest. What, Jack?
We need to be negative.
Why? What's wrong with having a negative answer? Discriminating? Okay, here's the problem. Everybody take negative 2, which was one of our answers. Plug it in for angle B. what's going to happen? You're going to have a negative angle, which I cannot have. All right? So that's why -2 has to be rejected. Please listen carefully. I am not rejecting -2 because it's negative. I am rejecting it because when I substitute it back in, what does it cause? A negative angle to be formed. All right? Again, I am not getting rid of it just because of the fact that it's a negative answer. Who cares? I can have positive and negatives, but when I plug it back in, it gives me a negative angle. No go. No go. Any issues with you guys? One more together, and the last one is in your group. Ooh, triangle PQR, beautiful. Measure of P is twice Q. All right, how do you want to start labeling this bad boy then? Measure of P is twice the measure of Q. How are we starting this out then? P is twice the measure of Q. Hi, Riley. P is twice Q. The way you gave me.
I mean, like Q, do X for Q.
Yep.
2X for Q.
There you go. Yep. P is twice Q, and then looks like I have a exterior angle at vertex R. So again, how do I make an exterior angle? Extend one of the sides at vertex R. Again, take a look. You can do it like this if you'd like, or if you really want to get crazy, you can do it like that if you want. Okay, as long as you extend R in one direction. And what's that angle? 120? Got it. Okay, can you please apply the theorem I've given you? Don't find the angle next to 120 and do it that way. Can you please apply the theorem we've been using? 15, have an equation using that theorem? The two remote interiors equal the exterior. Beautiful job, Gracie. So I end up with x is equal to 40. Go back, reread the problem. What was I asked for? Q, what did we call Q? X, okay, we're good. And this final one, you guys are going to do as a big crew here in your groups. Oh, look who makes a reappearance. AB is parallel. Oh, there's got to be some type of special angles up there. Yep. Angle X is 44. And angle Y is 98. You guys have to find those three angles up there. I will write the answers up on the board, so once you and your group is done, you can check them to see if you're good to go.